This is our heart library. We have over 200 human hearts that have been donated by organ donors whose hearts weren't fit for transplants. And if they have good enough function, we'll reanimate them and we'll be able to look at the internal anatomy while the isolated heart is functioning.
And we've cannulated these hearts, dilated them so they hold an end diastolic shape, or as if they were full of blood, and then they are permanent specimens like that. And we've been able to use different imaging to look at the structures. So we can use MRI, we can use CT scans, or we can do 3D echo probes to look at the static anatomy. And with the static specimen, you can best assess the structural differences from one heart to the next.
Here are good examples of the differences in sizes. This is a pediatric heart. This is a relatively healthy heart. Most of the hearts we receive have some sort of disease state, which is why they weren't fit for transplant. So this is about the size of a healthy heart. You can see there's minimal fat. There will always be some amount of fat around the veins for a protective layer. This one is an example of an enlarged heart. It's also hypertrophic. The person had a history of high blood pressure, so the heart had to work harder to pump against that high blood pressure, and as a result, like any muscle, it compensates by increasing in size. Here are two hemisections to show two extreme cases of heart failure. This one on my right is an example of dilated cardiomyopathy, so that the tissue has kind of degraded, so the heart walls are slightly thinner than they would be in a healthy heart, and you can also see that the shape is more rounded instead of this apex shape. This is also an example of, again, a hypertrophic heart. So this wall thickness is way thicker than you'd expect in a healthy heart. And you can also see that one downside is that the chamber size is a lot smaller, so it's a less efficient pump because you're pumping less volume with every beat. So these two hearts are examples of some of the hearts that we have that came with devices in them. This heart is an example of a mechanical aortic valve replacement. So you can see inside there's a bileaflet mechanical valve. So this is an example of a biventricular pacing device. So it paces the right ventricle with a pacing lead in the right ventricular apex. And it's also interesting, you can see the lead has fibrosed into the valve, which is part of the body's natural response to a foreign object. And they stimulate the left side, which is what most of my research is on, by putting a lead into the cardiac venous system. So you can see the lead enters into the coronary sinus, and you can see again it's fibrosed into the tissue. And it wraps around in this vein, where it will then pace the left side from the outside.